Well, good morning, everybody. We're here for our first session of the last day of NAB 2023. I'm Wes Simpson. I'll be your moderator and one of the speakers today. Our next speaker is Nick Katsampekis, and Nick is with Pebble Broadcast, who does a lot of work in control. So it's very appropriate that he's going to be talking about IS-12, which is the next generation of NMOS specification specifically designed for control. So take it away, Nick.
Thank you, Wes. Hi, everyone. Thank you for attending this show. As Wes gave me a good introduction here, my name is Nick Katsampekis. I'm the product owner for Pebble Control. Pebble Control is a connection management and control solution that has been built to leverage interoperable technologies, including the NMOS suite of specifications. As you can see in the graph that we're showing here, we have a variety of NMOS applications that they exist at this stage, and for the past 5 years they've been utilized in many tools, devices, and control interfaces. And we have a new application specification that is coming up in API, the IS-12, and this is what we're going to be talking about today and how it can help us to simplify workflows within our industry. Pebble is an organization that is heavily involved in the NMOS initiative. We co-chair and heavily contribute to the M1 NMOS modeling activity and specifications. And we have contributed to the open source device and control simulation application for IS-12. This way application can be downloaded from the GitHub, and anyone can use it to emulate an NMOS IS-12 control interface that they can test against or add into their controller. We are active contributor to many other NMOS activities, and we participate in all the JTNM and interoperability events. But before we go too far, I just wanted to take a step back for the audience that they might not have the experience or had the opportunity to understand some of this terminology that I just used and some of the terms. Especially, I would like to take you through a little journey why interoperability is important and what does it actually describe. When we talk about interoperability in our industry, it's all about different applications and devices to be able to interact meaningfully between them, to be able to exchange information in such a way that they can get tasks done easy and in a simpler manner, that we don't get bottlenecks, things that don't get stopped. That's what interoperability is. It's a concept that we live every day anyway, and we should be trying to apply it in our industry into a great extent. MWA is an organization that is championing interoperability through open standards, and it's an open forum, and with members from both media organizations and their suppliers. They develop these specifications and technologies to help us to deploy in an efficient way media workflows. Through MWA, we have a variety of documentations that help us to understand and implement interoperability. We have application specifications, documents with a prefix of AS in front of them. We have data modeling specifications. Those are their documents with a prefix of MS in front of them. And also we have the interface specifications, like in this case, the IS-04 that everyone is aware of, and the same thing for IS-12 that we're going to be talking about. On top of that, through M1, we also find applications and documents that they're best current practices, and those that are described with the term BCP. And there is another set of informative documents with the prefix of info that contain information that is helpful to the media industry. NMOS, the title of Network Media Open Specifications, engulfs open and free chart specifications that they are published by M1 and they help, as I mentioned earlier, to establish interoperability between media devices on an IP infrastructure. What does actually mean open protocols and specifications? What do they actually describe? So when we say that something is open, we mean it's freely available to exchange. It has been created through collaboration from different vendors and people that they have interest in our industry, okay? They can be our clients that they contribute and they tell us what they need, and they can be us that we all work together to come into a common conclusion to solve a task. It's a community-oriented development and is free to be distributed to all of us. And that's something different from what we have experienced over the years with working with closed or proprietary protocols that maybe they have been created by a single vendor. Okay. These open protocols, they're used by systems like an NMOS broadcast controller. And an NMOS broadcast controller in our world is a software application that utilizes the NPIs. And they help us to discover, connect, control, and in general, manage the resources from multiple vendors, and like the devices, the senders, and the receivers. If any one of you want to find out a little bit more information about broadcast controller, in the M1 website you can find info 005, and it's very clear what is expected from an NMOS broadcast controller. You can use that information when you're approaching vendors for RFPs, and vendors obviously they can use that information and make sure that their controllers comply with the recommendations that they found in this document. So how do we make sure that things that they've been created and made available and they're open, they're actually tested and in essence regulated, but not by fixed permissions, but more like it's tested and we know that it works approach. So JTNM is a group, is a self-coordinating group of industry bodies that are made by well-established professional bodies and individuals like the M1, MT, VSF, and EBU, that all of them working together to ensure that we develop something that will help IP technologies to help our industry to move forwards in to what we want to achieve in this case. And there is a testing program. It's called JTNM Tested. It's a well-defined and executed test on how vendors can develop their equipment and make sure they test them against to ensure that it confirms with parts of the SMT standards, M1 and NMOS specifications, and selected real-world scenarios. Now we're getting towards the topic that we're going to be discussing here, the IS-12 control protocol. It's an NMOS open interface specification, as we said, and it describes a standard way of exposing NMOS control models which can be consumed and interacted with. It's a two-way JSON-based protocol and on top of a WebSocket secure communication. Anyone that is following the rules and the requirements specified in IS-12 and the supported documents can be implement the NMOS device control protocol on the devices and controllers. What I'm showing you here is a little example from an NMOS controller that discovers an NMOS device over ISO 4. And on top of that, we can see the same device exposing IS-12 control parameter capabilities. And once you have this in the same system now in your broadcast controller, you have the freedom to create a flexible workflow that is fully transferable to many applications. Now you might ask yourself, well, why do we need another protocol? Okay. Obviously, what we said, this is an open protocol. Its aim is interoperability. Okay. It's supported and it's developed by MWA with an involvement both of end users and vendors at the same time. So you get greater view of the world on what we expect from the industry, what our customers expect, and what we need to deliver. Okay. And we will benefit from the future JTNM bench testing activities. So our work is going to be tested, and you have confidence that what is done, it will work immediately in your workflow. Okay, so we're taking some of the risk away with a protocol like this. So that's what is going to help us to do, bring the barriers down that they're normally found with exchange of information between vendors. As a result, we will simplify and speed up deployment of end users' workflows. That's the overall objective, what we want to achieve here, to be able to deliver something quickly and predictable. Now, broadcast workflows, as you know yourselves, they have many similarities, okay? But also they are very unique. They're very bespoke and specialized. And why is that? Because every end user, it will have their own requirements. They're not going to be the same for everyone. There's going to be a percentage that thinks they're similar, but there's going to be specific unique elements with it. And those uniqueness, it can be also extended because they're using different type of equipment from different vendors. And every piece of kit might have some added functionality that another piece of equipment doesn't have, so it cannot be utilized in every workflow, right? So let's take, for example, a broadcast facility. It can be an OB track, it can be a studio, it can be a playout or a distribution center. All these environments, they have a common requirement. They will have a lot of incoming feeds that they will need to normalize somehow before they actually use them and move them into the next stage in their process. They might have to do some additional tasks. One facility might have certain requirements, another facility might have different requirements, as we already mentioned. But nevertheless, they will need to do some interaction with the workflow, within the workflow, and there will be equipment that they will be used for that to provide that solution. I'm really sorry, it seems to be jumping every time I click. So for example, take the device that I'm showing here. It's a sophisticated device. It can have many applications. It can provide many solutions. You can do branding, you can do video processing, you can do audio processing format. And, you know, that's great. You have a device that can satisfy quite a few requirements, maybe from a typical workflow that is normalizing incoming feeds. And all those elements, they will expose some control parameters that we need to control and configure. It can be switching an audio channel to the gain, adjusting a video program, adjusting a color corrector, or applying a logo on and off into your workflow. But when you have devices, from my experience anyway, when you have devices that they are combining a lot of functionality, what do we do find that they do cost a little bit more. And also, they might be great in one area, but they might not be that great in another area. And they can introduce multiple single point of failures in your chain if you try to put everything in one box, okay? On on top of that, when you aggregate a lot of functionality within one device, you might find yourself that this device doesn't have an expansion path anymore because the hardware has been maxed out on his capabilities. There is no space on what you can do anymore further there. So what does that mean? Well, it means that typically we will actually not have a single device. We will have multiple devices that are providing the elements of your workflow. And when you have multiple devices within your workflow, that means that we're going to also have multiple control layers because they're more likely to come from different vendors, and your system architect is more likely to have selected the best of breed to satisfy his needs at that point, right? But from managing the delivery of the workflow, this can become very complicated and a big task. You will need to write different drivers, different interfaces. There is delays, there are added costs with that, and complexity. Sometimes you go down the path and you find that there is a technical limitation. And if you find the technical limitation, you will get to the point that it might delay the deployment of your workflow until all the third parties come together and find a common solution. And trying to do that and find people to agree and work together in your time frame, it might not be suitable for them, and it might add you more delays into your project. So what we're saying here is, will it not just be great that we have one control protocol, one entity that everyone has agreed and is well defined, is open, is distributed, and people have contributed to it. They have agreed in advance on how it's going to be implemented and how it's going to be deployed. Because once we do that, we just remove all that complexity layer from our deployment of a workflow, right? We have one driver, everyone knows how it's done, everyone knows how to interact with it, and what we said earlier, we might have JT&M tests. We do have JT&M tests, and we will have JT&M tests for IS-12 integration that people can run on their own, and they can evaluate it and make sure that they're compliant. So that is another element here, is that we remove the risk when we introduce a new device that it might not work well with others, okay? So what does it mean having an IS-12 device compatible protocol, an NMOS device? Well, it means that now with the suite of applications that we have already, APIs, we're not only going to discover the devices over NMOS, we're going to be able to expose their flows and make connection managements, like to the routing element. But now we can see their properties from that device at the same time, and we can expose what parameters that device shows through a single layer of application, okay? Simplifying things. And once we can dive down deeper to that device, pick what we are interested in our workflow, map it in our profiles, and work with it. And we can expand on the properties what we have. Okay, what we're showing here is a possibility on how a master gain control can be shown on an IS-12 compatible device. We all know what a gain does. It's a numeric slider. We all know that it's going to have a minimum and a maximum value, and more likely to be represented in dB and what range it has. So why can we not agree on these parameters, or at least agree on a subset as minimum requirements? So when we have a device in the market, we know that there is a minimum set that device it will satisfy. So that means it can be used in our workflows very quickly. And what do we mean used in our workflow very quickly? Okay, so say for example, you had in your workflow designed a customer panel interface, okay? They was talking to a device that was already compatible, and now you want to add a new one, okay? That means I don't need to go and recreate that panel. The only thing that I need to do is point it to a different device because it supports the same command set, it supports the same functionality, okay? So that device can be from a different manufacturer, it can be from the same manufacturer, it can be a different flavor of that same device, but it just happens to have the same command. So everything is mapped nicely in that case. So it simplifies how we can deliver these workflows. I don't need to write another driver, basically. What does that mean for the vendors, from the other hand? So we saw the benefits of a user, that he can reuse his workflows, and it means he can deploy his workflows quicker. From the vendor, it means he doesn't need to spend time reinventing the wheel, okay? Let's put it like this. You know, you can focus your time on doing USPs and making your product more approachable to solve real-life solutions, rather than spending your time on defining a communication protocol, a brand new communication protocol. We have the communication language done, we have the modeling already done, so that means we can reuse our work, okay? And we can focus on what is matters for all of us. And there is no limitations on what parameters we can map with IS-12, okay? We can do numeric sliders, we can do buttons, we can do switches. Anything that we need to map, they can be modeled and agreed and defined in advance. Just showing you a few examples of screens of the devices and how they can be represented. So as you can see, we can actually create complex workflows from multiple vendors' IS-12 devices in that point and bring them into one graphic. And that means we simplified that workflow because we don't need to worry about if this device will work well with the other device that I just added in my system. And obviously, you know, say for example, we had a failure in our system, okay? And I'm looking at my stack of devices that I have available to me, and I need to pick one quickly and plug it into my system. Okay, we're going to have some time to do some wiring perhaps. We might have to do some basic network configuration, but don't need to go and change my workflow. I plug this device, I point it to it, and it should talk the same commands and control the same controls in the same kind of way. Okay, so it takes that risk of things to be able to work together away. Okay, so I think I have overrun a little bit here, but I just wanted to summarize some of these points kind of thing that we just make throughout the presentation. IS-12 is an open protocol, okay? Specification is in working in progress from EMOA, so there's still work is being done. We are aiming to have the specification done for IBC timeframe, so more announcements are going to be done over there. And the key benefits that I want you to take away from this is that it will allow us to utilize the best of breed devices within our workflows to deliver quickly any workflow that utilizes this protocol in their devices or in their control layer. It's all about reusability and interoperability within our industry, basically. If you need to find any more information, I recommend that you visit the MY website. There is a lot of documents there that they explain and give examples on how the IS-12 modeling is done and what it's all about and the protocol. And there is also an information document in there that you can look, and there is also the open source emulator device application that you can download and start using and developing against. And as a final note, I would like to also mention that the IS-12 now it has made it on the EBU pyramid, so there's a lot of work that is done there. And if you're a vendor, I really encourage you to participate with the MOA and contribute to it. That's the whole point, that we contribute and we share our views and knowledge to get something done better. And if you're a customer, please speak to your vendors and tell them what do you think they're going to be doing if they're coming up with new products in the future. Thank you for that, and I'm happy to take any questions, but I know we overrun.
Nick, we're fine on time. That's okay. We can take a question or two.
That's great. Thank you.
Anybody has any questions? Yeah.
How is 12 connected to AS70?
Sorry,
Is
could you
there-
repeat that again?
How is IS12 connected to AES70? Is this
AS17.
70? Is there a connection between those two protocols?
No, I'm not. I wouldn't say there is any connection at this stage.
Okay. Yes, sir.
Yeah, you were talking about the parameter control of the devices, and I think it's very important to get one step beyond this of the control block specifications. And I'm curious what is involved for a vendor to contribute new ones. So if we have a not supported type of device like in Q or a limiter or something, to have a low burden to contribute a new specification of this type
Yeah.
of device.
Yeah, no, it's a very good question here. As we mentioned, the protocol is championed by vendors and also users. Vendors, they are welcome to join the M1 committee, and they can contribute their views there, and they can provide information. Or you can speak to your users, and your users, if they're members, they can also contribute. And you can also individually put your ideas forward into M1 to take all this into consideration.
Anybody else? All right, Nick, thank you very much.
Thank you for your time.